Hello. In this video, I want to discuss one last example of a curve described by a vector function. Now remember that for a vector function r defined on an interval I, say with values in R2 or in R3, the range of this vector function can be interpreted as a curve in R2 and R3. Well, this is not always the case, but sometimes. Right? So the curve we're looking at is a set. Right? It's a set of all possible values of our vector function. Now, one important example is where the vector function is given by the following. So r of t is, say, c cos t, c sine t, and we let t range, say, from 0 to 2 pi. Then in this case, the curve we get is a circle. Right? The center of this circle is the origin, 0. And the radius is c. Now, from this basic example, we can make a range of different examples. We've already looked at one. Now let's look at another one. So here we've got vector function r of t, 2 cos t, 2 sine t plus 2, and 3. Right, so this is a three-dimensional vector function, right? And it's defined on the interval 0 to 2 pi. Right? So our r maps this interval 0 to 2 pi into R3. Right? So the range of this vector function should be a curve in R3. Right? Now we want to identify this curve and sketch it. Now, looking at the first two components here, right, that kind of looks familiar. Right? It's very much like the circle we discussed a moment ago. Right? So let's see, we can write our vector function r of t as vector function u of t plus 0 to 3. And what is our u of t? Well, u of t is 2 cos t to sine t 0. And again, for t between 0 and 2 pi. Now, let's call k the range of u. So in other words, all the possible values of the vector function u. Right? And again, because this is a three-dimensional vector function, this is going to be a curve in R3. Now, what can we say about k? Well, the first thing that we can note is that the z component is 0. So that means that our curve k is contained in the xy plane. So that's all the vectors or points of this form. Right? The xy plane. So we can basically, just for the moment, ignore that first component. Right? The third component, the 0. Right? And then what have we got? If we just look at just the x and the y components. Right? So for k, we look at the x components. That's 2 cos t, and the y component 2 sine t, and again t between 0 and 2 pi. Right? So if we ignore the third component for the moment, we see that what we've got here is again a circle. Right? And it's a circle with radius 2, right? Because of the coefficients there, they tell you the radius. And the center is 0, right? But now this is 0 in R3, and the circle is contained in the xy plane. Right? So in other words, there's K in the xy plane. Right, circle with radius 2. Now, how do we get C from K? Well, we notice that X, a point in R3, is on the curve C if and only if X is a value for R for some t, and this t must be between 0 and 2 pi. But we can write R as u of t plus this 0, 2, 3. Right? So what could we say? This guy is on K. Right? So that means X will be in C. So on the curve C, if and only if we can write X in this form. Y plus 0, 2, 3, where Y is some point on the circle K. Right. So let's break this down a little more. So we've got if and only if X is equal to Y plus 0, 2, 0 plus 0, 0, 3. Again, for some Y and K. So what does that tell us? Right? So what is the effect of adding that 0 to 0? The effect of adding that 0 to 0 is a shift. So adding that 0 to 0 shifts the curve 2 units to the right. And likewise, adding 0, 0, 3 has the effect of shifting the curve 3 units up. Right. So what have we got? We've got C is K shifted 2 units to the right in the positive Y direction. Plus 3 units up. Right. So what does that tell us? Well, let's see. Here we've got K, right? The circle in the XY plane, center there at the origin, and with radius 2. Right? So we take this curve and we add 0 to 0. So that means we just shift this whole thing 2 units to the right. Right. So we just take the circle and we pick it up and we move it 2 units to the right. Right. So now we've got the circle in the XY plane. There's its origin at 0, 2, 0. Right, and again, its radius is 2. Right? And now we add 0, 0, 3. Right? So this has the effect of shifting the curve upwards by 3 units. Right? So we shift the curve 3 units up. So we take the curve here, right, this one here, and we just pick it up and we move it 3 units up. Right. So now, there's the center of our circle now. We've moved it 3 units up, so it's gone from 0 to 0 to 0 to 3. Right? It is radius 2, right, going from here to there, right, and it sits in the plane z is equal to 3. Right. So our curve C is a circle in the plane z equals 3. Its radius is 2, and its center is at 0, 2, 3. Right. So notice that we went from just knowing the circle in the plane with center at the origin, and then we noticed that, well, all we're doing is we're moving it 0, 2, 0, so 2 units in the right, there, and then 0, 0, 3, 3 units up. Okay, and this idea can be applied in more general situations, not just to circles. So if you have a familiar curve, and you have a new curve that you can write as that curve plus some constant vectors, then you can draw a sketch of the new curve by simply shifting the sketch of the old curve.